Welcome to our new video. Last time we stopped at multiplication of matrices. We were about to start with the multiplication, but luckily enough, time wasn't on our side. So today we are going to study multiplication of matrices. Last time we studied addition and subtraction of two matrices. We say we can only add or subtract two matrices if they have the same order. So today we are going to see multiplication. But first, before we start multiplying two matrices, we will see how to do a scalar multiplication for matrices. This is a type of multiplication involving matrices and scalars. So these scalars can be numbers, can be parameters, can be whole numbers, fractions, or integers. So this is what we mean by scalar multiplication. This means multiplying each entry of the matrix by the given number of parameter. So let's illustrate this with a simple example. Example, let A, B, C be the given matrices. A is this matrix 1, 0, 3, 2. B is minus 1, 4, and 1, minus 2. C is 2, 3. So we want to find 4A minus 3B, 4A minus 3B, and C over 2. C over 2 is the same thing as 1 over 2 times C. So first we want to see 4 times A. Here our scalar is 4 and A is our matrix. The next example, minus 3B. Our scalar here is minus 3 and our matrix is B. 4A minus 3B. If you find 4A, then add it with minus 3B. This is just like saying add 1 and 2, because 1 is 4A and 2 is minus 3B. So if you add it, you will have 4 minus 3B. 4 is C over 2, which is 1 over 2 times C. So let's see. This is just simple. I said multiplying each entry by the given parameter. In this case, our parameter is 4. Our scalar is 4. So this is 4A. 4 times our A. A is matrix 1, 0, 3, 2. So 4 times 1, 4 times 0, 4 times 3, and 4 times 2. Multiply each entry by this given number, scalar, or a parameter. In case I give alpha, if I ask you to find alpha A, just alpha times each entry will give us our result. So this is 4A. 4 times each entry, you have 4 times 1, 4, 4 times 0, 0, 4 times 3, 12, 4 times 2, 8. So 4A is the matrix 4, 0, 12, 8. So this is 4A. 2 minus 3B. In this case, our parameter or our scalar is minus 3. So minus 3 times B. B is the matrix. So minus 3 times B is just like saying minus 3 times each entry of the matrix. So minus 3 times minus 1, minus 3 times 4, minus 3 times 1, and minus 3 times minus 2. So the result is 3 minus 12 and minus 36. So this is scalar multiplication. So now the next example is to find 4A minus 3B. If you look at the first example is 4A. The second one is minus 3B. So the third one is just saying add it, because 4 plus minus 3B is 4 minus 3B. So we are just adding 4A minus and minus 3B. So 4 minus 3B is just saying 4, 0, 12, 8, which is our 4A, plus, and this, the other matrix is minus 3B. So 4A minus plus minus 3B. So you have 4 plus 3, 12. 0 minus 12 is minus 4 plus 3 is 7, sorry. 0 minus 12 is minus 12, and 12 minus 3 is 9. 8 plus 6 is 14. So this is 4A minus 3B. The last example is C over 2. C over 2 is just saying half of C. Half of C is 1 over 2 times C. So this is saying multiply each entry by 1 over 2. So 1 over 2 times 2, which will be 1, and 1 over 2 times 3, which is 3 over 2, which is 1.5. So this is the scalar multiplication. There are so many examples. I will send the examples to you so that you will try it and see. There are so many examples, of course simple ones and the complex ones. So provided you understand the procedure, then you can solve any example under scalar multiplication of matrices. Next is the matrix multiplication. So how do we multiply two matrices? Before, we show how to add two matrices and how to find the difference between two matrices. We say we can only add or subtract if the order is the same. So let's see what is the criteria for multiplication. The condition for addition is if the order is the same. So for us to multiply two given matrices, there must be a condition that that must be satisfied. So let's see, two matrices A and B are said to be multiplied together, A times B. A times B, please. There is difference between A times B and B times A in matrices. In real numbers, if you have 2 times 2 times 3 is the same thing as 3 times 2. But in matrices, it is not always true. So if you have A, if you want to multiply A by B, there must be a condition, please. The order, I mean the order of the multiplication is very important here. So two matrices A and B are said to be multiplied together, that is A times B, if and only if the number of columns of the first matrix is the same as the number of rows of the second matrix. Like as I was saying, you can only multiply two matrices if the number of columns of the first matrix is the same as the number of rows of the second matrix. I have matrix A and I have matrix B. I want to multiply A times B. Okay, if the number of columns of A is equal to the number of rows of B, then multiplication is allowed and is possible. Otherwise, you can never multiply these two matrices. So note, first, the number of columns of the first matrix must be equal to the number of rows of the second matrix. Also, if you want to multiply B times A, number of columns of B has to be equal to the number of rows of A. So the order is very important. B times A might not be equal to A times B. So please take note. So if this condition is satisfied, then we can multiply these two matrices. So let's see an example on how to make this multiplication, because it is different from the addition or subtraction we did, and the scalar multiplication is different. So let's see how the procedure looks like. So examples, given A equal to this, B equal to this, and C equal to this, find the following where possible. So find the following where possible. Check and see, we have like 11 examples, 11 questions under this. A times B, check, can we multiply A and B? If yes, then multiplication is possible, then go ahead and find the result. If it is not possible, then stop. Just conclude by saying multiplication is not defined, or we cannot multiply these two matrices. Why? Because the number of columns of the first one is not equal to the number of rows of the second one. So let's see. We have A to be a 2 by 2 matrix, B 2 by 3, and C 3 by 3. Well, let's see. The first one is A times B. I have matrix A and I have matrix B. So how can I find A times B? First, the first thing to do is to check the number of columns of A. As I said in the example, if you check it, the matrix A is a 2 by 2 matrix. I mean, the order of A is 2 by 2. and the order of B is 2 by 3. So matrix A has two rows, 2 columns. Matrix B has 2 rows, 3 columns. So 2 columns, 2 rows. So the number of column of the matrix A is the same thing as the number of rows of the second matrix B. So multiplication is possible. As you can see, if you check the slide, I highlighted the number of columns of A with light blue color and the number of rows of B with light red. So it's for you to know the matrix A has 2 columns and the matrix B has 2 rows. So they are the same. I use A, which is 2 by 2. And in our last discussion, I showed how to represent the order of a given matrix with an notation A, then subscript 2 times 2, which is A 2 by 2. So A is 2 by 2, B is 2 by 3, so 2, 2. So number of columns of A is equal to the number of rows of B. So we can multiply these two matrices. Check the number of columns, check the number of rows, they are the same. So this is Z. Hence, multiplication is possible. If multiplication is possible, then we can multiply. So let's see how we multiply these two matrices. A is 3 minus 1, 0, 1. B is 2, 6, 4, 8, 5, 7. Okay, this is how the procedure is. The rows of A times each column of B. First row of A multiplying first column of B, then second column of B, then third column of B. So first row multiplying first column, second and third, then second row will also multiply first column, second column and third column. So if you look at the first row, I have 3 and I have minus 1. So check 3 times 2, that is the first entry in matrix A times the first entry in matrix B. So 3 times 2 plus second entry in the row of matrix A times the second entry of the row of matrix B. So it's like this times this. The first one times the first one, the second one in the column times the second one in the row. So it's row times column. So 3 times 2 plus minus 1 times 8. You can only understand it if you look at the slide. If you look at the slide, this is 3, this 3 times this 2 plus minus 1 times 8. So the multiplication is going this way, this. So this will give you the first entry. The second one, the same row multiplying the second column. So the same row, I have 3 times 6, which is in the second column, and plus minus 1 times 5. So this first row will multiply each and every column of the second matrix. The first row of the first matrix will multiply each row of the second matrix. The second row of the first matrix will multiply each column of the second matrix. So it's row times column, and the first row again times the next column. So no matter how many columns you have, that row of the first matrix will must multiply each and every column of the second one. So look at it, we have 3 times 2 plus minus 1 times 8. This is the first entry. Then 3 times 6 plus minus 1 times 5. Then 3 times 4 plus minus 1 times 7. So the row has multiplied each and every column. So the first row has finished its job. So now is the second row. The second row also will multiply each and every column of the second matrix. So I have 0 times 2 plus 1 times 8, then 0 times 6 plus 1 times 5, and 0 times 4 plus 1 times 7. So row times column. This row times this column. This row again times this column. So each row we must multiply each and every column of the second matrix. This is matrix A and this is matrix B. Each row of the first matrix must multiply each column of the second one. So if this is the row, this first row will multiply this column, then the same row will multiply this column, the same row will multiply each and every column. So multiply, add, it will give you the first entry, multiply, add will give you up to the number of columns and rows you have. So this is this. I have 6 times my, the result is 6 plus minus 8, and perform the addition and subtraction and you will have your result. So AB is this. Let me come again. You are given two matrices A and B. We want to multiply these two matrices. First, a condition has to be satisfied. That condition is the number of columns of the first matrix has to be equal to the number of rows of the second one. So A here is 2 by 2 and B is 2 by 3. So number of columns of A is 2, number of rows of B is 2. So they are the same. So multiplication is possible. We can multiply these two matrices. So how? This is A and this is B. Let's say this is the rows of A and this is B, the column of B. The first row will multiply this column, this column, this column, and this column, and the rest, no matter how many columns you have. If the first row has finished multiplying each and every column, then the second row will take over. Second row multiply by each column. Third row multiply by each column up to the number of rows and columns you have. So if you look at this, A is 3 minus 1, 0, 1. B is 2, 6, 4, 8, 5, 7. So the first row of A is 3 and minus 1. So this row must multiply these 3 columns of B. So the first number is 3. 3 times the first entry plus the second number times the second entry. That is all for the first entry of the multiplication. This next one, that same row will multiply the next column. That same row will multiply the next column. So if the first row has finished multiplying each and every column, then the second row will take over and multiply each and every column. So look at the slide. I have 3, this 3 times 2 plus minus 1 times 8. Then 3 times 6 plus minus 1 times 5. Then 3 times 4 plus minus 1 times 7. Then the first row has finished its job. So now the second row, which is 0, 1. 0 times 2 and plus 1 times 8. 0 times 6 plus 1 times 5. 0 times 4 plus 1 times 7. So perform the multiplication and the addition. Then you will have your result. AB is minus 2, 13, 5, 8, and 7. So this is AB. The next example is AC. We want to multiply A and C. Count the number of columns of A, which is 2. Count the number of rows of C. It has 3 rows. This has 2 columns and this has 3 rows. So multiplication is not possible. Here A is a 2 by 2 matrix and C is 3 by 3 matrix, which implies the number of columns of A is not equal to the number of rows of B. Hence multiplication is not possible. Therefore A times C is not defined. Number of columns of A is 2. Number of rows of B is 3. So 2 and 3, 2 is not equal to 3. So multiplication is not possible. Just conclude that A times C is not defined. As simple as this. Next is BC. Can we multiply B times C? Let's see. The order of B is 2 by 3. The order of B is 2 by 3, and the order of C is 3 by 3. So B has 3 rows, and B has 3 columns, and C has 3 rows. So 3 equal to 3. So number of columns of B is equal to the number of rows of C. So multiplication is possible. How do you multiply? Each column of B, each row of B must multiply each and every column of C. So B is 2, 6, 4, 8, 5, 7. C is a 3 by 3 matrix. So the first row of B is 2, 6, 4. 2, 6, 4. This 2, 6, 4 will multiply each and every column of C. So look at the slide. 2 times 1 plus 6 times minus 5 plus 4 times 2. So the row has multiplied the first column. 2 times 1 plus 6 times minus 5 plus 4 times 2. We have finished with the first entry of the multiplication. Next is still the first row will multiply the second column. So you have 2 times minus 3 plus 6 times 0 plus 1 times 4. That is the second column. Next, this first row still will multiply the third column. You will have 2 times minus 4, 6 times 11, and 4 times minus 2. You have finished with the first row. Once the first row has multiplied each and every column, then it has finished its job. So next is the second row. Second row is 8, 5, 7. 8 times 1 plus 5 times minus 5 plus 7 times 2. That is the second row times first column, second row again times second column, second row again times the third column. So second row is multiplying second column. I have 3 times 8 times minus 3, 5 times 0, and 7 times 1. So 8 times minus 4, that is second row times the third column. 8 times minus 4, 5 times 11, and 7 times minus 2. So this after multiplying and adding, the result is minus 20, minus 2, 50, minus 3, minus 17, and 9. So this is BC. Remember, B has 2 columns and C has 3, B has 2 rows and C has 3 columns. So first, to multiply C and B, number of columns of B has to be equal to the number of rows of C. If that condition is satisfied, then addition is possible. How do we add? Okay, each row of B will multiply each and every column of C. So first row times first column, first row again times second column, first row times third column. This has finished. Then the second row times first column, second row times second column, and second row times the third column. So if you multiply, add, and you will have your result. So try the other examples, because I have like 11. I ask like 11 of them. Multiply and see. First check, is the condition satisfied? If yes, proceed. If no, just conclude that multiplication is not possible, so we cannot multiply. If it is possible, then perform the multiplication. So in the example, I ask you to find A squared. A squared is just like A times A, and A times A is very possible. If the order of 2 matrices are the same, then automatically you can multiply these matrices. If they have the same order, don't waste your time, just proceed and multiply. Because if their order is the same, their number of rows must be the same, and their number of columns must be the same. So if they have the same order, just proceed and perform the multiplication. So a squared is a times a. Don't go and start squaring each and every entry. It is wrong. A squared is a times a. Just like 2 squared is 2 times 2. So a squared a times a, b squared b times b, and c squared is c times c. So if you check the examples, if you have any difficulty, just ask and I will answer your questions. So check the examples. We have AB in bracket, then C. I am saying first multiply A times B, then the result multiply it with C. Check if it is possible. If it is possible, multiply. If it is not, don't. You cannot multiply. If you check the examples, in the first one, we found our result to be a given matrix, which is AB. Try finding BA. If B times A is equal to A times B, then we will say in that instance, then they are equal. But in general, they are not equal. Just like in this example, you will see AB is not equal to BA, because BA cannot be, it's not possible to multiply B times A, because the number of columns of B is 3 and the number of rows of A is 2. So you see, you cannot have BA. You can have AB, but you cannot have BA. Check and see. So you see A times B is not equal to B times A in this particular example. So in general, it is not the same. We have AC. We couldn't find AC, and we also couldn't find, you cannot, maybe you can find CA. The number of columns of C is 3, and the number of rows of A is 2. So you cannot also find that. So BC, we have our results. So try finding CB. So compare and see. In some instance, it may be the same, but in general, it is not equal. So check and see. So this is this. So next thing is the transpose. What do we mean by the transpose of a matrix? Definition. If A is an m by n matrix, that is the number of rows is m, number of columns is n, we are going to generally define what a transpose is. If A is an m by n matrix, the transpose of A, written A power t, that is A transpose. A power t is A transpose. Is the matrix, is the n by m matrix whose rows are just the columns of A in the same order. If you have your matrix A, which is m by n, that is the order, the transpose of A is just reversing the matrix A, which is n by m. So the columns, this is A and this is A transpose. Columns of A will become the rows of A transpose. Rows of A will become the columns of the A transpose. Just transposing. If this is A, then A transpose will be something like this. So if you have your A with its rows and its columns, if you want to find the A transpose, just make the rows of A to be the columns of A transpose, and vice versa. So in other words, the first row of A transpose is the first column of A. The second row of A transpose is the second column of A, and so on. So let's see this. Let's see an example. Write down the transpose of each of the following matrices. A is 1, 2, 3, B is 5, 2, 6, and C is this. And we have D also. So look at it. A is 1, 2, 3. A transpose will be just something like this. That is transpose the matrix. A is 1, 2, 3. If we want to find A transpose, all we have to do is transpose, is make the columns of A the rows of A transpose. Just like this. If you look at the slide, This is A 132, but A transpose is 132. We have transpose it. B is 526, and transpose of B will be 526. The columns has become the rows. So C transpose is this, and D transpose is this. D transpose, luckily enough, is equal to D. So by transposing, changing the columns, the rows of A to be the columns of A transpose, that is transpose. Just the rows will now become the columns of the transpose matrix. So this is transpose. So try and see. Just if this is A, these are the columns of A and the rows of A. A transpose will be something like this. So you see the columns has now become the rows of A transpose. So now, special type of matrices. We have the square matrix. A matrix is said to be square if the number of rows is equal to the number of columns. That is square matrix. If you have the number of rows of that matrix to be equal to the number of columns of the matrix, then we call it a square matrix. So next time we will give some special type of matrices like 4 or 5. Then we start with the determinant. So thank you. See you later.